set up a small business to assemble computer keyboards. That's my startup cost. That's my initial cost, right? All right. So his initial cost was $120,000. I think he's selling more than popcorn. That's a lot of popcorn. And your unit cost to assemble each keyboard is $40. What does he mean by unit cost? Any idea? Actually, what they mean here by the initial cost is like the cost of the machine, the popcorn popper, okay? And then each time you sell a bag of popcorn, you have to pop a quarter of a cup of popcorn, right? Each time you sell a bag of popcorn, you have to pop a quarter of a bag of popcorn in your popcorn machine. So if you were to relate this to a popcorn popper, the cost of the machine would be the $120,000. And the cost of the consumables that you need to make the popcorn, the oil and the popcorn itself, would be equivalent to the $40. Okay? So when they talk about the initial cost being $120,000, they're talking about the building and the machines that you need to build the computer tops. And then your unit costs are the actual plastic and stuff that goes into each of the units. Okay? It says, write an expression that relates your total cost to the number of keyboards produced. And then plot the total cost of producing 1,000, 2,000, 3,000, 4,000, 5,000 keyboards. All right. First of all, we need to write down what we have. We always, in these problems, we always should write what we have, what we're given, and then write what we want, okay? What were we given? We were given initial cost of $120,000. That's like for the building and the machines. If you produce one machine, it's going to cost that $120,000. If you produce 1 million machines, that $120,000 won't change, right? Okay. And then the unit cost, the cost to produce each machine was $40. So what's our total cost going to be? What do we need to know in order to figure out the total cost?
How many are going to be made?
How many are going to be made? So the total cost is going to be the number of tops made times what?
40.
Times the unit cost. I'm going to write it out. I'll put the numbers in a minute. Okay? Plus what we paid for the building. We're not going to multiply that by the number of tops we make, because we don't have to buy the building each time we make a top. But we have to buy the buildings initially, so we add that. All right. So that's our formula. Now we can write it like this. Cost, or C, equals the number times the unit cost plus the initial cost. We've written an equation. We can actually substitute numbers there. Equals, let's make the number that we make, let X equal the number of computers we make. If we let X equal the number of computers we make, we have C equals X times the unit cost, which was $40, plus the initial cost was $120,000. We've just created a formula that models the cost for making these computer tops. Normally, we write this $40 as a coefficient. It doesn't matter as far as the answer goes, because we're multiplying here. It doesn't matter whether the X is first or the 40 is first. And mathematicians like to see it like this, with the number and then the variable after the number. I'm not a mathematician though, so I'm not real particular. All right? So now it asks us, it says find we wrote the equation, we did that, and then plot the cost. It wants us to plot the cost of making 1,000, 2,000, 3,000, or 4,000. So if we've got a plot, we're going to need to build a table with our x and y variables. So we'll assume an x and we'll calculate our y. And they want to know if we have x equals to 1,000, 2,000, 3,000, 4,000, and 5,000. So, how do we do that? Well, we just take our equation here. I'm going to do this on another sheet of paper, and I'll come back to this and fill it in. Our equation was C equals $40 times X, which was, plus $120,000. Now, X equals 1,000. C equals $40 times 1,000 plus 120. 120,000. 1,000 times 40. You can do it on your calculator. It's $40,000. Plus 120,000. So 40,000 and 120,000 is $160,000. So when X is 1,000, Y is 160,000. X is 1,000, Y is $160,000. Now we'll let X be 2,000. So we're going to have C equals 40 times 2,000 units plus $120,000. Well, 40 times 2,000, you can do it on your calculator, is $80,000. Y'all have calculators? Y'all going to get them if you don't. Plus $120,000, well, that's equal to $200,000. And so we're going to put this on our table. When X is 2,000, Y is 200,000. I'll calculate one more of these for us. When X equals 3,000, C is going to equal $40 times 3,000 plus 120,000. 40 times 3,000 equals $120,000. You all can do that in your head, can't you? If you can't, use your calculator. Plus $120,000 is $240,000. So we'll put that in the table. X is 3,000, Y was $240,000. Now, I'm not going to go ahead, I'm just going to enter this data in, because I've shown you how to do the calculations. But if we were to plug in 4,000 for our X, the Y would turn out to be $280,000. And if we plugged in 5,000, the Y would turn out to be $320,000. And now we can plot that using graph paper. Now, we can plot using different scales on our X and Y axis. And that's how I would plot this. On our X-axis, I would have each I'll write the scale here. And I'll write x-axis, each mark equals 1,000. And on our y-axis, each mark will equal 40,000. Okay? So I'm gonna draw a new graph. If I'm gonna do that, I better put that. Well, we can do it this way. 40, 80, 120, and 40 would be 160, 200, 240, 280, 320, and 360. All right. So this was 120, this was 40, this is 120, this is 200. So this one was 160, this one was 240, this one was 320, this one is 80, and this one is 40. All right? It's a little hard to see that, but do you understand what I did there? Okay. And then we can make this scale different. Here's 1,000. Here's 2,000. Here's 3,000. Here's 4,000. Here's 5,000. All right? So we can't do that. I made a mistake. Look at, I switched the scale here. You don't have to be consistent. That's a good mistake to make. It shows, it proves a point. When you're graphing, when you start out with the scale, on this scale I was going over 3 little hash marks, 1, 2, 3. I have to go over 3 all the time. For every 1,000 I have to go over 3, or my graph is going to be funny. It's not going to turn out right. Here, every mark was 40,000. Here, every 3 marks was 1,000. I can do that. So this is 4,000, and this is 5,000. So let's graph our data. 1,000 was 160. So here's 1,000 on our x. Here's 160,000 on our y. We'll put 3 zeros here, meaning that we're going to attach 3 zeros to the end of all these numbers. That's all that means. 2,000, our y was 200,000. That's right here. So that's our next data point. 2,000 on the x, 200,000 on the y. 3,000 and 240,000, which is right here. 4,000 and 280, which is right here. And then 5,000 and 320 brings us right to here. So here's our plot of that data. Okay? It's going to look a little different if you use a different scale or different spacing, but it's going to be correct. Okay? It's only going to be correct if you don't use consistent spacing. But you can establish a scale for your y, and you can use a different scale for your x. But you always have to be consistent in the spacing on that axis. Okay? Any questions?